distributive property. In order to go on to distributive property, I'm going to start with a little bit of review. When we have this problem, 5 touching the parentheses, and in the parentheses we have 3 plus 2. We would say this is 5 times the quantity 3 plus 2. Well, typically what we did in the past is we followed GEMDAS, order of operations, which I would do in this problem as well. Remember, the G stands for grouping. We look for the grouping first. Right here, we have in the parentheses 3 plus 2. And 3 plus 2 is just 5. But we still have that 5 on the outside touching the parentheses. Well, now, these are touching, and remember, touching means multiply. So when we multiply 5 times 5, we just get 25. Easy enough, right? Well, there's also a different way you can solve the same exact problem. But in order to be correct, remember, we should come up with the same answer because it's the same exact problem. So here's how distributive property works. When you have a number touching a whole parentheses, that number on the outside can distribute. It means give to everything. So we just have to give this 5 to everything inside the parentheses. And because it's touching, it's going to be multiplying. So we just have to multiply the 5 times the 3, but since it's in parentheses, we also have to multiply 5 times the 2. Well, 5 times 3 is 15, and 5 times 2 is 10. So since 5 times 3 is 15, I'm going to put that 15. In between them in the parentheses, I have a plus, and 5 times 2 is 10. Well, now when I add this together, 15 plus 10 is 25. See how these answers are exactly the same? It means we can solve these problems either way. I agree, this one is a lot simpler. The problem is, when we start to include variables in our problem, we're not going to be able to combine them like this. So that's why distributive property is really important. So let's get to some examples with those variables. So in this example, if we try to use order of operations, remember, which is GEMDAS, we would do what's in the parentheses first. But m plus 4 can't add together because remember, they're not like terms. So if they can't add together in the parentheses, then we can't use GEMDAS. So when we can't use GEMDAS, that's when we have to use the distributive property. So remember, since 3 is touching the parentheses, touching means, yes again, multiply. So the 3 has to multiply everything inside the parentheses. Because 3 is not just multiplying m, it's multiplying the whole parentheses. So 3 times m just means we have 3 m's. The biggest mistake people put is then they just put plus 4. Well, that's not the answer because this 4 is inside the parentheses, which is touching the 3. So that 3 also has to multiply the 4. And 3 times 4 is actually 12. So our solution would be 3m plus 12. And remember, I can't put those together because the 3 has an m and the 12 doesn't. So they're not allowed to combine. Why? Just like in the last lesson, they're not like terms. So as we move over here, it's the same type of problem. 2x and 3 can't go together, so this 6 multiplying on the outside has to distribute to everything inside. Well, 6 times 2 is 12, but that has an x. Then remember that 6 has to multiply that 3, and 6 times 3 is 18. On this problem, what's a little bit different is over here, since we had a plus sign, our answer had a plus. Well, in this problem, we have a negative sign, a minus sign. 6 times negative 3 actually makes negative 18. which means for our final solution, instead of having a plus, that negative makes it a minus. We can also have distributive property in the middle of a big problem. So we still have to follow order of operations and combining like terms, and now we're adding distributive property. So even though it looks complicated, really all this is combining three things that we've already learned. So first thing is we have to do the grouping, but remember we can't put those together. So that means we need to distribute. What's touching this parentheses is not 2. What? It's not 2. It's actually a negative 2. So when we distribute, it's not just 2 multiplying everything inside the parentheses, it's negative 2. So negative 2 times 3 is negative 6, and that has our m. Then the negative 2 also has to multiply the 5. Well, 2 times 5 is 10, so most people would bring a negative right there. Be careful. This is not just a 5, it's actually a negative 5. And when we're multiplying a negative 2 times a negative 5, remember, negative times a negative, 2 negatives cancel out. So that really becomes a positive 10. And this 9m is not in the parentheses, so that just means we have to bring it down for the next step. But that's actually not our solution. Why not? Because remember in the last lesson, the m can combine with the other m. So when we have like terms, we have to take this one more step. This 6m is a negative, the 9m is a positive, so different sign, subtract. 9 minus 6, I get 3 m's. And when I keep the sign of the larger one was positive, so it stays positive 3m. But then I still have this guy right here, the plus 10. Now, are those allowed to go together? No, because the 3 has an m and the 10 doesn't. So that would be our solution. As it gets a little more complicated, we have some examples that maybe have 2 sets of parentheses. Well, all that means is we just have to distribute twice. So the 5 has to distribute this first set of parentheses, and this positive 2 has to distribute to the second set of parentheses. So let's distribute. 5 times 2m, we get 10m. Then 5 times 3, we get a positive 15. 2 times 3m gets us a positive 6m, and a positive 2 times 1 gets us positive 2. Remember, we're not finished until we combine all the like terms. 10m's are allowed to combine with 6m's, which makes 16m. And the plus 15 is allowed to combine with the plus 2. And 15 plus 2 is a positive 17. At that point, we're finished because remember, those are not like terms. They can't combine any further.